The morning sun of Zephyria Prime cast strange purple shadows across the Galactic Engineering Academy as Jake Morrison walked through the massive crystal doors. The building itself seemed alive with energy flowing through its translucent walls. And Jake still felt amazed after 3 months of studying here. He was the only human among hundreds of alien students, and most days he felt like everyone was watching him. Jake entered the main lecture hall where Professor Vextel was already preparing for class. The professor stood nearly 3 meters tall, his body made of what looked like living crystal that caught and reflected light in beautiful patterns. His 4 arms moved gracefully as he arranged holographic displays in the air above his desk. Jake had learned that Professor Vextel was one of the most respected engineers in the galaxy, known for building structures that could survive anything. The other students filled the massive hall quickly. Jake sat in his usual spot near the back, trying not to draw attention to himself. To his left sat Zixandra, a being that looked like a cross between an octopus and a tree, with dozens of tentacles that moved constantly as she took notes. Her species was famous for creating buildings that grew themselves from seeds. Behind him sat Frumtak, whose insect-like body was covered in natural armor that sparkled like diamonds. His people built everything from crystals that sang in the wind. Professor Vextel called for attention and the room fell silent. His voice resonated through the crystal walls like distant thunder. He began speaking about their final exam, and Jake felt his stomach tighten with nervousness. This test would determine if he passed the course and could continue his studies. The professor explained that each student must build a shelter that could protect 5 people from a Class 7 meteor storm. Jake had read about these storms in his textbooks but had never seen one. The meteors would be traveling at 15,000 kilometers per hour and hitting the ground with the force of bombs. The shelter had to be built in 1 galactic day, which was about 28 Earth hours. Around him, the other students began talking excitedly about their ideas. Zixandra was already sketching something that looked like a giant flower made of metal. Her tentacles moved across her tablet so fast that Jake could barely follow them. Frumtek was calculating something on a device that projected numbers in the air around his head. Other students discussed using force fields, energy barriers, and materials Jake had never heard of. Jake listened quietly and tried to understand what he was up against. The meteor storm would be created using the Academy's advanced simulation technology, but it would be just as dangerous as the real thing. Students had been injured in previous tests, and some had failed so badly they were sent home in shame. Professor Vextel continued explaining the rules. Students could use any materials available in the Academy's vast storage facilities. They could build anywhere on the designated test grounds, an area about the size of 10 football fields. The shelter had to be finished and ready before the storm began, and it had to protect its occupants for at least 6 hours of continuous bombardment. Jake thought about what he knew of construction from Earth. His father had been a civil engineer who worked on bridges and buildings. During summers in high school, Jake had worked on construction sites and learned about concrete, steel, and the basics of making things strong enough to last. Most of his alien classmates seemed to think humans were primitive because they used such simple materials and methods. As the professor finished his explanation, students began forming groups to discuss their projects. Jake noticed that nobody approached him. He had tried to make friends during his time at the Academy, but most aliens seemed uncomfortable around humans. They were polite but distant, as if they thought he might do something unpredictable. CYX single quotes ANDR. A turned to him with what Jake had learned was a friendly expression among her people. Her large eyes blinked in sequence as she spoke. She told Jake that she was planning to grow a biological shelter that would heal itself if damaged. She asked what Jake was thinking of building. Jake admitted he was still considering his options. He had some ideas but wanted to study the problem more carefully before deciding. Zixandra seemed puzzled by this approach. Most alien students started building immediately. Trusting in their advanced technology and superior materials, Frumtek joined their conversation, his voice buzzing like a swarm of bees. He explained his plan to create a crystal dome that would vibrate at specific frequencies to deflect the incoming meteors. The crystals would absorb the impact energy and convert it into harmless light. He asked Jake if humans had any similar technology. Jake shook his head and explained that human engineering was much simpler. They mostly used basic materials like concrete and steel, relying on strength and clever design rather than advanced technology. Both aliens looked at him with what Jake interpreted as pity. Professor Vexthal approached their group, his crystal body casting rainbow patterns on the floor. He asked Jake how he planned to approach the challenge. Jake said he wanted to visit the test site and study the conditions before making his decision. The professor's crystalline features shifted in what might have been surprise. The other students had already begun requesting exotic materials and energy sources. Some wanted metals that could only be mined from the cores of dying stars. Others needed crystals grown in zero-gravity or biological materials that took months to cultivate. Jake's request was much simpler. He wanted to see the basic construction materials available and get access to standard earth-moving equipment. The quartermaster, a blob-like creature named Glixmore, laughed when Jake submitted his materials list. He asked if Jake was sure he did not want anything more sophisticated. Jake assured him that what he had requested would be sufficient for his needs. As the day ended, Jake walked to the test site alone. The area was a flat plain of reddish soil under the alien sky. He knelt down and picked up a handful of dirt, testing its consistency. He looked at the terrain, noting the slight slopes and drainage patterns. He thought about wind direction, soil composition, and how the ground might react to repeated impacts. Other students were also surveying the site, but they seemed more interested in where to position their energy generators or how much space their structures would need. Jake was thinking about something completely different. While they planned to fight the meteor storm, he was wondering if there might be a way to let the planet itself handle most of the work. As the purple sun set over Zephyr Prime, Jake made his decision. He would build something that his alien classmates would probably consider primitive and crude. But if his father had taught him anything, it was that the best engineering solutions were often the simplest ones. Tomorrow, while the others worked with their advanced materials and complex technologies, Jake would start digging. The second day began before sunrise as Jake made his way to the Academy's extensive material yards. The purple sky was just beginning to lighten, and most of his classmates were still sleeping. Jake had always been an early riser, a habit that served him well during his construction summers back on Earth. The material yards stretched for kilometers in every direction, filled with substances and equipment from thousands of different worlds. Jake walked past containers of liquid metal that flowed like water, crystals that hummed with internal energy, and biological materials that seemed to breathe on their own. Everything looked incredibly advanced and expensive. Glixmore was already at his station. His gelatinous body rippling with what Jake had learned was amusement. The quartermaster species communicated partly through color changes, and Jake could see waves of green and blue moving across his surface. Glixmore asked if Jake had changed his mind about his material requests overnight. Jake shook his head and confirmed he still wanted the same basic items: Portland cement, steel reinforcement bars, gravel, sand, and access to excavation equipment. Glixmore's body turned a darker shade of blue, which Jake interpreted as confusion or concern. The quartermaster asked if Jake understood what he would be facing in the meteor storm. Jake assured Glixmore that he knew exactly what he was doing. He had spent the previous evening calculating impact forces, studying the soil composition data, and reviewing everything he could find about Class 7 meteor storms. His approach might seem primitive, but it was based on solid engineering principles that had worked on Earth for centuries. Meanwhile, his classmates were having very different conversations with the quartermaster. Zixandra had submitted a request for biogenetic material that would take 18 hours to properly culture. Her shelter would literally grow itself, with living walls that could repair damage automatically. The process was elegant and sophisticated, but it required perfect timing and ideal conditions. Hrumtak needed resonance crystals that had to be grown in a zero-gravity chamber and then precisely tuned to specific frequencies. His crystal dome would be a work of art as much as engineering, capable of converting kinetic energy into harmless light displays. However, the crystals were fragile during the growing process and could be ruined by temperature fluctuations. Other students had equally complex requirements. Klixner, a gaseous being who kept his consciousness in a containment suit, wanted force field generators powered by antimatter cells. Tholmic, whose rocky skin made him look like a walking mountain, needed materials that could only be processed. In the Academy's fusion forges, by mid-morning, many students were already encountering problems. The biogenetic material for Zixandra's shelter was contaminated and had to be started over. Frumthak's crystals were growing too slowly because the zero-gravity chamber was being used by another student. Klixner discovered that antimatter cells were restricted materials that required special authorization. Jake, meanwhile, was making steady progress. His materials were simple, cheap, and readily available, while others waited for deliveries or dealt with technical problems. Jake was already at the test site with a small excavator, surveying the exact location where he would build. He had chosen a spot near the center of the test area, away from the drainage patterns he had observed the day before. The soil here was dense clay mixed with gravel, perfect for his purposes. Jake began marking out a rectangular area 15 meters long by 10 meters wide, using wooden stakes and string like construction workers had done on Earth for generations. Several alien students stopped to watch as Jake began digging. They seemed baffled by his approach. Vorthak, a tall being with skin like polished metal, asked Jake why he was making a hole in the ground. Jake explained that he was excavating the foundation for his shelter. Vorthak's metallic features shifted into what Jake recognized as confusion. He pointed out that the meteors would be coming from above, so building down into the ground seemed counterproductive. Jake smiled and said that was exactly why his approach would work. Professor Vexthal arrived at the test site around noon to check on his students' progress. He moved from project to project, his crystal body catching the alien sunlight and throwing rainbow patterns across the ground. When he reached Jake's location, he stopped and stared at the rectangular hole Jake had excavated. The professor asked Jake to explain his reasoning. Jake climbed out of the excavation, brushing dirt from his clothes. He explained that instead of trying to deflect or absorb the meteor impacts, he was designing his shelter to let the planet itself bear the brunt of the assault. The underground design would provide natural protection, while proper construction would ensure the structure remained intact. Professor Vexthal's crystalline features shifted as he processed this information. He asked about life support systems, structural integrity, and emergency access. Jake had answers for all of these concerns. He had designed ventilation systems that would function even under bombardment, multiple compartments to prevent catastrophic failure, and emergency exits that could be sealed from within. As the day progressed, Jake's approach began to look increasingly sensible compared to his classmates' struggles. Zixandra's second batch of biogenetic material was growing properly, but she was now running behind schedule. Frumthak's crystals were finally ready, but assembling them into a dome structure was proving more difficult than expected. Jake continued his steady work, mixing concrete and laying the foundation for his underground bunker. He used techniques his father had taught him, creating a reinforced base that would distribute loads evenly across the soil beneath. Every few hours he would stop to check measurements and make sure everything was proceeding according to his plan. Other students began to take notice of Jake's methodical approach. While they were dealing with complex technologies and exotic materials, Jake was making visible progress with simple tools and basic materials. His excavation was complete, his foundation was poured, and he was beginning to construct the reinforced walls. Zixandra approached Jake during one of his breaks, her tentacles moving in patterns that indicated curiosity. She asked how Jake could be so confident in such a simple approach. Jake explained that the best engineering solutions were often the ones that worked with natural forces rather than against them. Jake pointed to his excavation and explained how The earth around his bunker would absorb and dissipate the impact energy from the meteors. The reinforced concrete walls would provide structural integrity, while the underground design would protect the occupants from both direct impacts and the debris scattered by explosions on the surface. Hrumtek joined the conversation, his crystalline armor clicking as he moved. He admitted that Jake's approach had certain advantages over more complex solutions. If something went wrong with Hrumtek's resonance crystals during the storm, his entire shelter would fail. Jake's bunker, on the other hand, would continue to function even if individual components were damaged. As evening approached, the differences between the students' approaches became even more apparent. Many of the alien students were still waiting for materials or struggling with assembly problems. Some had realized their designs were too complex to complete in the remaining time. Others were discovering that their advanced materials were incompatible with local conditions. Jake, meanwhile, was nearly finished with his basic structure. The walls of his bunker were complete, and he was installing the steel beam framework that would support the roof. His work was proceeding exactly on schedule, and he would have time tomorrow to focus on the interior systems and final preparations. Professor Vexthal made another tour of the test site as the alien sun was setting. He spent considerable time examining Jake's bunker, asking detailed questions about the design and construction methods. Jake could see that the professor was beginning to understand the elegance of the human approach. As Jake gathered his tools for the day, he felt confident about his chances. While his classmates had focused on sophisticated technology and exotic materials, he had chosen to work with fundamental principles of engineering that had been proven effective for centuries. Tomorrow would bring the final preparations, and then they would all discover whose approach had been correct. The third day dawned with an urgency that filled the air like electricity. Jake arrived at the test site before any of his classmates, carrying a thermos of coffee and a bag of tools. The excavation he had dug looked like a precise rectangular wound in the reddish soil of Zephyria Prime, waiting to be transformed into something that could save lives. Jake began his work immediately, knowing that timing would be crucial for the final day of construction. He had calculated every step of his process, from the concrete mixing ratios to the steel placement patterns. While his alien classmates relied on automated systems and advanced technologies, Jake was doing most of his work by hand, the way human builders had done for generations. The first task was installing the roof structure. Jake had designed a system of steel I-beams that would distribute the load of the concrete ceiling across the reinforced walls. Each beam had to be positioned exactly, welded in place, and checked for proper alignment. The work was physically demanding, but Jake had spent summers doing similar labor on construction sites back home. As Jake wrestled with the heavy steel beams, other students began arriving at the test site. Their reactions to his progress were mixed. Some seemed impressed by how much he had accomplished, while others appeared confused by his methods. The excavation that had looked like a simple hole 2 days ago was now clearly recognizable as a sophisticated underground structure. Zixandra arrived looking worried, her tentacles moving in agitated patterns. Her biogenetic shelter was growing properly, but much slower than she had expected. The living walls were only half their intended height, and she was beginning to doubt whether they would be ready in time. She stopped at Jake's bunker and watched him work, her large eyes blinking in the sequence that indicated deep thought. Jake noticed her watching and took a break from his welding to talk with her. Zixandra asked how Jake could work so calmly when the deadline was approaching so quickly. Jake wiped sweat from his forehead and explained that he had planned his construction schedule carefully, allowing extra time for unexpected problems. Hrumtek arrived shortly after, his crystalline armor reflecting the morning light. His crystal dome was taking shape, but the assembly process was proving more complex than anticipated. Several of the resonance crystals had developed hairline cracks during installation, and Hrumtek was worried about structural failure under stress. His people's technology was beautiful and sophisticated, but it required perfect conditions to function properly. Jake continued his steady work while observing his classmates' growing difficulties. Klixner had finally received authorization for his antimatter power cells, but the force field generators were overheating during testing. Thomic's fusion-forged materials were incredibly strong, but they were also incredibly heavy, and his foundation was beginning to crack under the weight. By midday, Jake had completed his roof structure and was beginning to pour the concrete ceiling. This was the most critical part of his construction, requiring precise timing and careful technique. The concrete had to be mixed to exact specifications, poured evenly, and allowed to cure properly before the meteor storm began. Jake worked methodically, using a concrete mixer and pump system that would have seemed primitive to his alien classmates. However, his technique was flawless, developed through years of watching experienced construction workers and practicing during summer jobs. The concrete flowed smoothly into the forms he had built, creating a ceiling that would be strong enough to withstand repeated impacts. Professor Vexthal arrived during Jake's concrete pour and watched the process with growing interest. The professor's crystalline features reflected the afternoon light as he observed Jake's precise movements and careful attention to detail. He asked Jake about the concrete mixture and curing time, clearly impressed by the human's knowledge of materials science. Jake explained that the concrete he was using was a high-strength mixture designed for impact resistance. The aggregate size and Portland cement ratio were optimized for the specific loads they would face during the meteor storm. The steel reinforcement was positioned to handle both compression and tension forces, creating a structure that could flex without breaking while Jake worked on his ceiling. The problems with other projects were becoming more apparent. Zixandra. Biogenetic shelter was still growing too slowly, and she was beginning to consider backup options. Rumtak had replaced 3 cracked crystals, but the dome assembly was taking much longer than planned. Several students were starting to panic as they realized their sophisticated designs might not be completed in time. Jake's approach was looking increasingly sensible by comparison. His materials were simple and reliable, his construction methods were proven, and his progress was steady and predictable. While others struggled with exotic technologies and complex assembly procedures, Jake was following a straightforward plan that moved him closer to completion with each passing hour. As the afternoon progressed, Jake began installing the interior systems of his bunker. He created separate compartments for different functions: sleeping areas, food storage, water supplies, and a central command area. Each space was designed efficiently, maximizing functionality while minimizing wasted volume. The ventilation system was perhaps the most sophisticated part of Jake's design. He installed a network of air ducts and filters that would maintain breathable atmosphere even if the surface access was blocked. The system included manual backup options and multiple redundancies, ensuring that occupants could survive for days if necessary. Jake also installed emergency lighting powered by batteries, communication equipment, and a water filtration system. Everything was designed to function independently, so the failure of one system would not compromise the others. This redundancy was a key principle of human engineering that many alien civilizations seemed to overlook in favor of elegant but fragile integrated systems. By late afternoon, several students had admitted defeat. Vorthak's energy barrier system had suffered a cascade failure during testing, leaving him with no time to rebuild. Klixner's force field generators had overheated. Beyond repair, and replacement parts would not arrive until after the deadline. 3 other students had encountered similar problems with their advanced technologies. Jake, meanwhile, was putting the finishing touches on his bunker. He tested all systems multiple times, checked every connection, and verified that emergency procedures would work under stress. His structure was not as visually impressive as some of the alien designs, but it was completely functional and ready for the coming storm. Professor Vexthal made a final inspection tour as the day neared its end. He spent considerable time in Jake's bunker, examining the construction details and testing the various systems. Jake could see that the professor was beginning to understand the sophistication hidden beneath the apparently simple design. The professor asked Jake about his confidence level for the coming test. Jake replied that he was as ready as he could be. His bunker had been designed specifically for the conditions they would face, using materials and methods that had been proven reliable over centuries of human construction experience. As the alien sun set over Zephyria Prime, Jake sealed the entrance to his bunker and ran through a final systems check. Everything was functioning perfectly. His classmates were still scrambling to complete their projects, but Jake was finished and ready. Tomorrow would bring the meteor storm, and then they would all discover whose approach had been correct. The test site fell quiet as students made their final preparations. Jake's bunker sat unnoticed among the more dramatic alien constructions. But it was the only shelter that was completely ready for what was coming. While others had built upward with advanced materials and complex technologies, Jake had gone underground with simple tools and proven methods. In a few hours they would learn which philosophy of engineering was truly superior. The final morning arrived with an ominous feeling that seemed to press down on the test site like a heavy blanket. Jake woke early in his dormitory room and looked out the window at the alien landscape. In just a few hours, the meteor storm simulation would begin, and everything he had worked for would be put to the ultimate test. Jake ate a light breakfast and made his way to the test site one last time before the storm. The area was buzzing with frantic activity as his classmates made desperate last-minute adjustments to their shelters. The contrast between their panic and Jake's calm confidence was striking. Zixandra was tending to her biogenetic shelter with obvious desperation. The living walls had grown to about 3/4 of their intended height, but they were still soft and vulnerable. Her tentacles moved frantically as she tried to stimulate faster growth using chemical accelerants. The shelter looked beautiful, like a giant flower made of translucent organic material, but it was clearly not ready for the punishment it would soon face. Hrumtek was having even worse problems with his crystal dome. 2 more resonance crystals had cracked during the night, and the frequency tuning was completely off. The dome looked magnificent in the morning light, casting rainbow patterns across the ground, but Jake could see stress fractures in several of the larger crystals. The structure was as fragile as it was beautiful. Other students were in similar situations. Klixner had managed to repair one of his force field generators, but the power output was insufficient to protect the full area he had planned. Tholmec's fusion forge structure was incredibly strong, but the foundation cracks had worsened overnight, and the entire building was leaning at a dangerous angle. Jake walked calmly to his bunker and conducted a final inspection. Everything was exactly as he had left it the night before. The reinforced concrete walls were solid and properly cured. The steel framework showed no signs of stress or deformation. All interior systems were functioning perfectly. His shelter was ready. Professor Vexthal arrived at the test site with a team of monitoring specialists who would observe the test from a safe distance. The professor's crystalline body seemed to pulse with nervous energy as he surveyed the various student projects. When he reached Jake's bunker, he paused and examined the entrance carefully. The professor asked Jake to explain his design one more time, and Jake was happy to oblige. He led Professor Vexthal through the entrance tunnel and into the main chamber of the bunker. The space was larger than it appeared from outside, with 5 meters of concrete and earth between the occupants and the surface above. Jake showed the professor how the multiple compartments would prevent catastrophic failure if one area was damaged. He demonstrated the ventilation system that would continue working even if debris blocked the main entrance. He explained how the water storage and air filtration systems could sustain 5 people for several days if necessary. Professor Vexthal examined the steel reinforcement patterns in the concrete walls, running his crystalline fingers along the beams. He asked detailed questions about load distribution, impact absorption, and structural redundancy. Jake could see that the professor was beginning to appreciate the sophisticated engineering hidden beneath the apparently simple construction. The professor commented that Jake's approach was fundamentally different from typical galactic engineering practices. Most civilizations focused on deflecting or absorbing impacts using advanced materials and energy systems. Jake had chosen instead to work with the natural protective qualities of the planet itself. Jake explained that this was a common approach in human engineering. Rather than fighting against natural forces, humans often found ways to redirect those forces or use them to their advantage. The bunker design allowed the Earth above to absorb most of the impact energy, while the reinforced structure below remained protected. As they climbed back to the surface, Professor Vexthal asked about Jake's confidence in the design. Jake replied that he was certain his bunker would perform as expected. He had used materials and construction methods that had been proven reliable in similar situations on Earth for hundreds of years. The professor paused at the bunker entrance and looked around at the other student projects. Many were still incomplete, and those that were finished looked increasingly fragile compared to Jake's solid construction. The professor's expression was difficult to read, but Jake sensed that his alien instructor was beginning to understand the value of the human approach. With 2 hours remaining before the test began, the panic among Jake's classmates was becoming obvious. Zixandra was trying to reinforce her bioshelter with metal supports, destroying the elegant organic aesthetic she had worked so hard to achieve. Frumtek was desperately replacing cracked crystals, but each new installation seemed to create stress in other parts of the dome. Several students approached Professor Vexthal to request deadline extensions or design modifications. The professor denied all such requests, explaining that the test parameters had been established for good reasons. In real emergency situations, there would be no extensions or second chances. Jake spent the final hours before the test conducting one last systems check and reviewing his emergency procedures. He tested the air filtration system, verified the water supplies, and made sure all communication equipment was functioning properly. Every component of his bunker was designed to work independently, so even multiple failures would not compromise the overall safety of the shelter. As the deadline approached, Jake noticed that several students had abandoned their projects entirely. Vorthak's energy barrier had failed completely, leaving him with no protection at all. 3 others had similar problems with their advanced technologies. Their sophisticated designs had proven too complex to build and maintain under pressure. Professor Vexthal gathered all the students for a final briefing about the test procedures. The meteor storm simulation would begin in 30 minutes and continue for 6 hours. Students would remain in their shelters throughout the bombardment, and any shelter that failed would result in automatic failure for its builder. The professor explained that the simulated meteors would have the same kinetic energy as real ones, capable of creating craters several meters deep and destroying anything in their path. The bombardment would be random and continuous, testing not just the initial strength of each shelter but its ability to withstand prolonged assault. Jake listened calmly to these instructions while his classmates showed increasing signs of nervousness. Some were making final desperate adjustments to their designs. Others were staring at their shelters with obvious doubt about their chances of survival. When the briefing ended, students began entering their shelters for the test. Jake took one last look around the test site, noting the variety of approaches his classmates had taken. There were energy barriers, crystal domes, biogenetic growths, and fusion-forged structures. His simple concrete bunker looked almost primitive by comparison. Jake climbed down into his bunker and sealed the entrance behind him. The interior was quiet and comfortable, with enough space for 5 people to live safely for days if necessary. All systems were functioning perfectly, and Jake felt confident that his design would perform exactly as planned. Above ground, the test site fell silent as the final preparations were completed. In just a few minutes, the meteor storm would begin, and Jake would discover whether his faith in human engineering principles had been justified. The simple concrete bunker that had taken him 3 days to build was about to face the ultimate test of its design and construction. The meteor storm began with a sound like thunder that never stopped. Jake sat in the central chamber of his bunker, listening to the impacts above as simulated meteors struck the surface at 15,000 kilometers per hour. Each impact sent vibrations through the ground, but the reinforced concrete walls around him remained solid and steady. Jake had positioned monitoring equipment throughout his bunker to track the performance of all systems during the test. The displays showed that air quality remained perfect. Water pressure was stable, and the structural integrity monitors detected no stress beyond normal parameters. His design was working exactly as intended. Above ground, the destruction was immediate and devastating. The first wave of meteors created a landscape of craters and flying debris. Jake could hear the impacts through his ventilation system, but the sounds were muffled and distant. The earth above his bunker was absorbing the tremendous kinetic energy of each impact. Just as he had planned, the bunker's communication system allowed Jake to monitor what was happening to his classmates. The results were heartbreaking. Zixandra's biogenetic shelter had been one of the first to fail. The living walls, still soft and incomplete, had been shredded by debris from the initial impacts. Her elegant organic design had proven no match. For the brutal reality of the meteor storm, from Tak's crystal dome had lasted slightly longer. But the stress fractures Jake had noticed that morning proved fatal. The resonance crystals began shattering under the repeated impacts, creating a cascade failure that brought down the entire structure. The beautiful rainbow patterns that had decorated the dome became deadly shards of crystal flying in all directions. Klixner's single remaining force field generator had overloaded within the first 10 minutes of the bombardment. The energy barrier flickered and died, leaving him completely exposed to the continuing assault. Thomek's fusion-forged building had toppled when its cracked foundation finally gave way under the combination of structural weight and impact vibrations. One by one, Jake heard the emergency signals from his classmates as their shelters failed. The sophisticated technologies and exotic materials that had seemed so advanced just hours before were proving inadequate against the raw destructive power of the meteor storm. Complex systems were failing in ways their builders had never anticipated. Professor Vexthel monitored the test from a protected observation post several kilometers away. His instruments showed the catastrophic failure of shelter after shelter as the bombardment continued. Energy barriers collapsed, crystal structures shattered, and biogenetic materials dissolved under the assault. Only one shelter continued to show stable readings on all monitors. Jake's bunker not only survived, but thrived during the storm. The concrete ceiling, reinforced with steel and protected by meters of earth, absorbed impacts that would have destroyed surface structures. The multiple compartments prevented any single failure from compromising the entire shelter. The redundant life support systems continued functioning flawlessly throughout the bombardment. 2 hours into the test, Jake decided to move around his bunker and inspect different areas. He found that some sections had small cracks in the walls, where particularly large impacts had occurred directly overhead. But these were superficial damage that did not affect structural integrity. The steel reinforcement was doing its job, distributing loads and preventing catastrophic failure. Jake prepared a simple meal using the supplies he had stored in the bunker. The normalcy of eating lunch while meteors pounded the surface above seemed almost surreal, but it demonstrated the effectiveness of his design. His classmates who had built more sophisticated shelters were struggling to survive. While Jake was comfortable enough to maintain normal routines, the storm continued. For the full 6 hours as planned, with no decrease in intensity. Jake used the time to test all of his emergency procedures and backup systems. Every component of the bunker performed exactly as designed. The air remained fresh, the water stayed clean, and the temperature remained comfortable throughout the bombardment. As the storm finally ended, an eerie silence fell over the test site. Jake waited an additional 30 minutes to ensure the bombardment had truly stopped before beginning his emergence procedures. He unsealed the entrance tunnel and climbed toward the surface, not knowing what he would find above. The test site had been transformed into an alien moonscape of craters and debris. The ground was torn and scarred, covered with fragments of the destroyed shelters. Where elegant structures had stood just hours before, there were now only piles of twisted metal, shattered crystal, and unrecognizable wreckage. Jake emerged from his bunker to find Professor Vexthel and the monitoring team approaching across the devastated landscape. The professor's crystalline features showed what Jake had learned to recognize as amazement. The simple concrete bunker entrance was unmarked, except for a light coating of dust and small debris. Professor Vexthal descended into the bunker with Jake, examining every detail of the structure. The professor's instruments confirmed what the monitors had shown throughout the test. The bunker had maintained perfect environmental conditions while withstanding impacts that destroyed every other shelter on the test site. The professor asked Jake to explain once again how his design had been so successful when more advanced approaches had failed. Jake walked the professor through his reasoning, explaining how working with natural forces rather than against them had been the key to success. Jake showed how the earth above the bunker had absorbed and dissipated impact energy that would have overwhelmed any surface structure. The reinforced concrete had provided exactly the right combination of strength and flexibility to handle the remaining loads. The multiple redundant systems had ensured that even if some components failed, the shelter would continue protecting its occupants when they returned to the surface. Other students were emerging from the Academy's emergency shelters where they had waited out the storm. They gathered around Jake's bunker in amazement, unable to believe that such a simple structure had survived when their sophisticated designs had failed so completely. Zixandra approached Jake with her tentacles moving in patterns that indicated deep respect. She admitted that she had underestimated both Jake and human engineering principles. Her people's biogenetic technology was elegant and efficient under normal conditions, but it had proven inadequate for extreme survival situations. Hrumtuk's crystalline armor was cracked and dulled, reflecting his dejection over the failure of his dome. He told Jake that he was beginning to understand why humans had survived and thrived on their challenging home planet. The ability to build simple, reliable structures using basic materials was more valuable than he had realized. Professor Vexthal addressed the gathered students, his voice carrying newfound respect for human engineering. He acknowledged that, while the other students had pursued sophisticated solutions requiring advanced technology, Jake had demonstrated superior engineering by working with fundamental principles and readily available resources. The professor explained that Jake's approach represented a philosophy of engineering that the galactic community had overlooked. Rather than trying to overcome natural forces with technology, humans had learned to work with those forces and use them as allies. This perspective offered valuable lessons for engineers throughout the galaxy. Professor Vexthal announced that Jake's bunker would become a permanent installation at the Academy, serving as a teaching example for future students. The structure would be preserved exactly as Jake had built it, demonstrating how effective solutions often came from understanding basic principles rather than applying advanced technology. The professor also announced that the Academy's curriculum would be updated to include courses on human engineering principles. Students from across the galaxy would learn how humans approach problems differently, focusing on reliability and simplicity rather than complexity and sophistication. As the evaluation concluded, Jake's classmates approached him with requests for guidance on their future projects. The same aliens who had dismissed human engineering as primitive just days before now recognized that humanity offered a unique and valuable perspective on construction and survival. Jake accepted their requests graciously, understanding that this moment represented more than just his personal success. He had demonstrated that human ingenuity and practical problem-solving could compete with the most advanced technologies in the galaxy. The simple concrete bunker that had taken him just 3 days to build had proven that sometimes the most effective solutions were also the most straightforward ones. The alien sun was setting over Zephyria Prime as Jake gathered his tools for the final time. His test was complete, his bunker had succeeded beyond all expectations, and his approach to engineering had earned respect throughout the galactic academic community. He had proven that human methods, often dismissed as primitive, could be superior to advanced alien technology when applied with intelligence and understanding.